Morning, students. In this lecture, we are going to discuss about array in C. Right. Now, we consider an array. Right. So, array is a consecutive memory location. So, here, suppose you are having now that integer of 10 element, then integer of 10 elements are here we are having that memory. So, first element, second element, third element, and fourth element, and so on. So, if you are declaring that variable int of a of 10. Now we are having that element. This is a of 0, first element, and then the final one as a of 9. So that is here n. So 0 to n minus 1, 0 to n minus 1 size, right? Now what it is actually, we'll see that one. In C, an array is a linear data structure. Array is a linear data structure stored a fixed size. So we are having now the size is fixed size. The sequential collection of element of the same data type in contiguous memory location. So same data type means first one is integer, second one integer, and so on. All elements are integer only. So that is called same data type. So integer only. So this is the same data type, integer type only for each and every element. 0 to 9 elements are integer type. So we can store 10 integer on the consecutive memory location. Consecutive means successive 1, 2, 3, and so on. So here if you are having this is one address, then the next address, next address, and so on. So contiguous memory location. Right. Now, what's the property of that array is homogeneous element. So that one does, if you are declaring one array with one type, then there is no change in the type. So this is, it may be integer, it may be float, or so we can declare that float f of 10. Then each element is float type only. So the float type is 4 bytes consecutively, one, right? Another 4 bytes and so here we are having now around 40 bytes are allocated. F of 0 is first one and f of 9 is the last one. We can store the floating point number and each and every consecutive location. Similarly, character array. So char of, if you are having that name is 50 character maximum. So we can declare that one as a name of 50 and we can store the character by character. So for 0 to 49 characters we can have now. Then here 0, name of 0. So here the name itself is the total array. Right? In character, float and so on, right? Now, contiguous memory. So, all elements are stored in a single unbroken block of memory. So, here there is no, in between there is no break. Unbroken block of memory. This allows for fast indexed access of any element. So, here, now we can have the random access. Random access means A of 4 means then it will give now 5th element. A of 8 means it will give now 9th element. And so on. Directly we can access the elements. Directly we can access the element. So that is we are having now that contiguous memory. The advantage of contiguous memory is we are having accessing that element fast and indexed access of any element. So here we can use that A of I. The I may be the index. So A of the index. Index, using that index, then we can access A of 0 and A of 4 and A of 9, 8 and so on. So indexed access we can have now. Directly we can access the element. Then here the size of the static array. So this is, if you are declaring that one, then A of 10 is, the 10 is fixed now. A of 10 is fixed now. So that is fixed size. We can't change that size at one time. If you are initializing or we also one time you are declaring, then it will allocate a block of memory. Then there is no change in size. Then here we are having 0 based indexing. So first element is A of 0. A of 0. So that element is 0 to n minus 1. If you are having n element, we can have now 0 to n minus 1 element. 0 to n minus 1 elements. 0 to n minus 1 elements. Next one is that one is array TK. What do you mean by the array TK is here we are passing an array with array name itself, right? So that is if you are having we are calling a function. On that function you are passing the array. Then here we are having that passing that array. If you want to print the here we want to print the array. So we are having that function print array. Then you have to pass the end a of the size. Then we are having now end the size of memory. So here you have to pass the print array with a the followed by the size. Now the a itself is a first element address. First element address is a of 0. Then we are having the consecutive, we are giving now that one as 10 element. So we are passing now. So that is called array TK. When an array is passed to a function, when an array is passed to a function, it TK into a pointer. So that is it's a pointer. Then we'll see the pointer later. So this, if you are the name itself, array name itself is a pointer to the total array. Then the first point is the first element is point by a. Then we can go for further element by indexing. So first element. As a result, the function loses the information about the array's original size. So original size we have to attach. So you don't know that size. If you are passing single a itself, then we don't know size within the function. So you have to always you have to pass the size also. Then using the size, then we can access the element. Right, then we'll see that one by one. So how do you declare that an array? So one dimensional array, the data type. So this is the data type. The data type may be integer, float, or character. Then the name of the array and what's the size. This is the declaration, right? So end numbers 5. So we are having now 5 elements. So here we can have the index 0 to 4 for each element, right? So that is here we are having now the numbers 2 byte. Suppose you assume that one 2 byte per integer, then another 2 byte per integer, another 2 byte, and so on. So this is 0 to 4 element. Then the name itself, the total array numbers. Then we are having the multi-dimensional array, two-dimensional array for accessing the for representing that matrix, right? So the matrix is the 2 rows 3 columns, right? So this is we are having now integer matrix 2 rows and matrix 2 rows and 3 columns. Then here we are having actually in memory it will have the consecutive 6 element, 2 into 3 6, 2 into 3 6 element. So first row is 2 elements, and second row another 2 element, and third row another 2 element, right? So this is each column. So one row. So this is row 1, row 2, row 3. The each row we are having now column 1, column 2, column 3, column 1, column 2, column 3. Then here we have column 1, column 2, column 3, row 2. Then row 3, column. So here we are having now A of 1, 1, A of 1, 2, A of 1, 3, A of 2, 1, A of 2, 2, A of 2, 3, and A of this row, right, column. Only these elements. Right? So that's R1, only R2, only two rows, right? Two rows, three columns, right? So the R1 and R2, then column each element 3 and another 3. So this is A11, A12, A13, A21, A22, A23. Right? We can have now the storage. So only two rows. So that one is, we are having now two rows, three columns. A11, A12, A13, A21, A22, A23. So arrange in the row major order form. So first row, second row, and so on. So this is in a single dimension only. So total 6 elements. And while declaration itself, we can initialize that one. We can initialize that number. Here directly we can go for that element, right? If you are declaring that one, then we are having that one garbage value. Garbage value is random value. So if you are having now declaration along with that initialization, it will give now initial that value. So that array is added with that element, right? So that is here 10, 20, 30, 40, and 50. We are having now 5 elements, right? So A of 0 to A of 0 to number of zeros to number of 4. We can have now initialization without specifying, right? So without specifying means then we will have that number is a random number. The compiler automatically determine the size based on the number of elements. So here without initialization, so without giving the number, but we are giving only 3 elements, so it will automatically put now the size is 3. Then partial initialization, right? So if you are initialize partially, right? So 5 element, but we are giving 2 element, the remaining element is going to have as 0. Automatically it will put now the value 0. If you are having now the number more than the size, then we are having only 2 element. The first 2 element it will take, remaining is filled with the 0. Now we'll see that. Here we are having now the integer score 3. Now we are, this is a random value, it will give no score. Then we can go for getting the value from the keyboard. Then we can have now one for loop, right? For loop we are going to discuss. Initially we are having that index is 0. Then it will go for checking now whether it is less than 3. Then it will go for the enter the score. Then you have to give now first value score 45. If you are typing that 45, now it will go to the ampersand of that score. So it will go to the first element. In that score, we are accessing first element. Then it will come is a for loop, then it will increment, and then it will check whether that is less than 3. Yes, then it will go for that one. Now the index of, this is index 0. Next index 1. The index 1 is going to store. Next, if you are giving that value 55, now 50, 58, then 58 will come now. Next one, here we are having now that next it will go for incrementing that next element, then I3. So I equal to 2, 0, 1, 2, right? 1, 2, then the condition is satisfied. Then it will get another score. It will ask another score. Now you are giving 75. Now the 75 is going to place on the index 2. Scores, right? Scores of 0, scores of 1, scores of 2. Store, and then it will go for that. No, once again then increment 3. Now 3, the condition is not satisfied, then the for loop is complete, then your program is come out. We are going to discuss in the for loop. At that time I will explain that one. Here this is the initialization, then condition, and then increment. Initialization, condition, increment, right? So initialization, condition, increment, or decrement. Initialization, condition, first one initialization, middle condition, and then increment or decrement in the for loop. We are going to see that. Here, how do you access the element array 3? Then we can have now first element, right? Array of 0. So directly we can give the index. So 3 element 10, 20, 30. Now 10. So it will give now 10. Next we are having array of 3, 120. Then we are having now, we can change that value with the array of 1. We are accessing that one as 25. Then in that value, we are replacing that one by 25, right? Then here we can use the pointer. The pointer is going to discuss elaborately later. Here you see that one P is a pointer. P is another location where we are storing the first address of the array. First address of array. P is a location where we can store the address. So your array is this one. Then my array. Then the my array first name itself is the address of that location. So this address. That address is going to placed on P. Now using that address, so currently it will show that first address. And then we are having now first value is stored print now. Next we are P plus 1 is, it will automatically, P plus 1 is, then it will represent the next address. So next element is going to see now. So P is 10, then next element is 20. Next, if you want to have the next element, then P plus 2. P plus 2 is the next element. So P plus 2 is the P is the current address. Then it will go further added with that next second element that. So in that element, so that element is 30. 30, here 20, here 10. So 30 is going to be print. Now if you are having now, then the second third statement, then we are having that my array of 2 is print now. So 30 will be printed. Right. Now, what's the advantage of that array, right? So array is memory efficient. So we are having consecutive memory is stored, then no other information is there. So store that element compactly in contiguous memory block. Minimize the overhead, right? So that is here one array with the size of that elements. Then we are storing now consecutively. Then using that index, then we can easily access. So access is very fast. So random access. A of 3 means then directly it will go for the corresponding location. So the complexity is 1. So only or directly we can get through address, we can get the element. So that is through the index we can have now access. Each element accessing time is only 1 unit of time. And easy traversal, right? So if you want to traversal, then we can use the for loop as like that one. So we are having that for loop. In that for loop, we can directly easily access that one. Using the for loop, we are having that index and easily access, right? So this is the case. Easily we can access the index. You can access the index easily, right? So this you can access the index easily. And what next? Index easily, right? So the foundation of other structures. So that one is here. We are going to see the next lecture is a data structure where we are going to discuss about the heterogeneous data type. We'll see now, right? Then here the disadvantage. What the disadvantage of that array is? Here the size is fixed, right? Initially, if you cannot resize after creation, then which can be lead to the waste of space if you are having the large A of 10, A of 100. Now we are using only 10 location, then 90 location is going to be waste, right? So it cannot be resized after creation. And then if you want to, while placing some data, suppose you are miss one data, if you want to place on that location, then you have to move all other element to one side, one level, and then we have to make a empty, and then you have to store that value. So insertion and deletion is somewhat tedious. Adding and removing an element require shifting all subsequent element, which is a slow operation. So if you are having around 100 size of that memory, now the first element I want to change, then all elements are move one step, and we have to make one make a room on the first one, and then we have to store the data. So insertion and deletion is somewhat tedious in that case of array. And then we are having no built-in pound checking, right? So pound checking is here we are having the size of the memory. Using the size of memory only, then we can have now how much you can access. Beyond which you can you are going now, then it is wrong result. So you have to give now you got index, then index size should be there. Then within that size, if you are having 0 to 19 only the index accessible. If a of 20 if you are accessing, then this is the wrong value. So that is we can have now. Next, homogeneous. Only the store the single data type, then mixed data type is not possible. So these are all the disadvantage of the array. Right. Here I told you that one we are having now the function, right? So print array is a function where we are passing the array name and then we are passing the size. Then only we can have a for loop and we can access each and every element in the function. So this is one function. This function will do now. It will get an array name and its size. Using array name and size, then using a for loop, then we can access each and every element and you can print that element. At the final, we are having now a new line character. Now here you see this one array is my data 1, 2, 3, 4, 5. Initialize that one. Now we want to have the size of that element, right? Then how do you get the size of the element? Is size of my data is one block of memory. My data is by name. It will give the block of memory divided by the each element size of my data 0 is the one element, right? If it integer, it will give now 4. If it is float, it will give 8. If it is character, it will give now 1, right? Then it will using this formula, then we can get the size of the array. So we are having the size here. We are having 4 element. 4 element is if you are having 4 byte 1, 4 into 5 20. So 20 byte is allocated. The 20 byte each element is 4. 20 divided by 4 we are getting now 5. So 5 elements we can get it now. Then we are passing the array. So we are passing that array is just by its name itself and then we can give the size. So name itself as then this name my data is going to be assigned to another pointer is here array. This array is now the my data. My data. So ARR is represent the my data. My data is the first location of the memory array. Now you are having the size. So using the size, then we can access the original data is my data, right? So my data is original data. My data is original data. Now the my data is passed on to here. Now using that one here, we are accessing that one to your memory. So here 1, 2, 3, 4, 5. Now we are printing now the content is 1, 2, 3, 4, 5. So in that function call, directly it will access your memory, your array through by name. So AR is by name, that the name is equivalent to that my data. So this is a pointer, as like a pointer is pointing to the my data is address. So this address. So using that address only we are accessing the each and every consecutive element. Each and every consecutive element, right? So that's all for a simple array, right? And we are going to see pointer and structure and we will explain in detail further. Here you are knowing a simple array. How do you declare and how do you access and how do you get the data? That's all. We can stop here. We will continue by another lecture.